Good evening, everyone. This is Abdulhakim Oluwadare Badmos. You're welcome again to our exciting edition of our mathematics clinic. I hope and sincerely believe you are feeling okay today. As I promised you, we shall be continuing today with uh, circle geometry as our topic for the day. I want to use this opportunity to say Ramadan Kareem to all our Muslim brothers, fasting Muslims across the world. Also, want to say happy Lent period to our Christian brothers also in the Lent period. May Almighty Allah continue to bless every one of us as we journey on this process. Right now, without wasting our time, we move straight to business. The business for the day is circle geometry. Circle geometry. But we cannot treat circle geometry without treating the properties of circles, because we shall be using a lot of terms from the properties of circles. If you don't understand the properties of circles, you find it very difficult to answer questions, or you find it difficult to understand some of the terms we shall be looking at. So what are the properties of circles we'll be looking at? First among the properties of circles we'll be looking at circumference. Circumference. Of course, we all know what a circle is. A circle is that any object in a round manner. That's a circle. So, one property we shall be looking at is circumference. What is circumference of a circle? Circumference of a circle is just defined as the total length surrounding a circle. So when we say circumference of a circle, we're saying the total length. If we are able to measure the total length surrounding a circle, then we're talking about the circumference of a circle. Yes, if you remember it, in our primary school days, they will tell us the circumference of a circle is calculated using 2 pi r. 2 pi r. It's not the pi in crypto world. Pi we're talking about here is 22/7. Right now, we also have something strange here. R. What is R? R there means radius. Having understood what circumference is, the next property to explain is the radius. What is radius? Radius of a circle is any line, straight line, drawn from the center of that circle to any point on the circumference. I'll come again. Radius of a circle is any line drawn from the center of the circle to any point on the circumference. So here we have that point. Then by the time you draw it and it touches the circumference, then you have drawn a what? A radius. Radius again is what? Is any line drawn from the center of a circle to any point on the circumference. So on the circumference of a circle, we can have so many radii. This is a radius. This is another radius. This is another radius. This is another radius. This is another radius. So we can have as many radii as possible. Remember, radius is singular, radii is plural. When we have many of those lines from the center touching the circumference, we call them radii. Moving forward, the next to talk about is diameter. I call it diameter. What is diameter? The diameter of a circle is that line that divides a circle into 2 equal parts. Any line that divides a circle into 2 equal parts. We talked about radius. We said surrounding is circumference. Now, I said any line drawn from, that passes through points on the that passes through the center of a circle and touches 2 points on the circumference is called diameter. So diameter divides a circle into 2 equal parts, meaning the part here is called a semicircle. The other part is also called a semicircle. So 2 semicircles make 1 circle. Isn't it? Yes, that is it. So that line that divides the circle into two equal parts is called a diameter. And one diameter has two radii. Remember, from the center to this point on the circumference, that is one radius. From the center to this point on the circumference, that is another radius, making one diameter equal to two radius. One diameter is equal to two radius. I hope you're following. Remember, we started from what is a circle? A circle is that round shape, plain figure. From there, what is a circumference? Circumference is the total length surrounding the circle. Next, what is radius? Radius is that line from the center of the circle to any point on the circumference. From the center to any point on the circumference. So we can have unlimited radii in a circle. Then I have diameter. Diameter is a line that divides a circle into two equal parts. Also, we can say diameter is a line that touches two opposite points on the circumference of a circle, passing through the center of the circle. Moving forward. The next property we'll be looking at is a chord. The next property is a chord. What is a chord? A chord is a line that touches 2 points on the circumference of a circle also, but does not pass through the center. If I have a circle, with that circle, this is the center. I then draw a line. It touches 2 points on the circumference, but does not pass through the center. That makes this a chord. Am I clear? Hope I'm communicating. Yes. That line that touches 2 points on the circumference without passing through the center of the circle is called a chord. Another layman's definition we can give a chord is a line that divides a circle into two segments. For instance, it divides the circle into two parts. The smaller part is a minor segment, while the bigger part is a major segment. The bigger part is the major segment, the smaller part is the minor segment. That is another property of circle we must talk about. Is any line that divides the circle into two segments, or is any line that touches 2 points on the circumference without passing through the center. Moving on. The next property to look at is sector. What are sector? Or what is a sector? A sector of a circle is any portion of a circle enclosed by two radii and an arc. Hello? Let me clean this. If I clean this and draw what I'm talking about. A sector, this is the center. Then I draw a radius. I draw another radius, making two. Then, if I cut out this portion, this is done at an angle. Let me call it angle theta. If I call it angle theta, then that portion, if I cut it out, I have this. Then I have theta, radius. This portion is a sector. I cut it out from this circle, remember? Then I will have this other remaining part of that circle. Isn't it? I have divided this circle into this. Now I have a minor sector, the smaller portion, and a major sector. Just as I had a minor segment and a major segment. Yes. This one is also a minor sector and a major sector. So, a sector is a portion, a region, a part of a circle covered by two radii and an arc. An arc is a portion of the circumference. So from here to here is an arc. As if I have to remove this, that is an arc. You know, if I remove this from the total circle, I have something like this left to complete the circle. These are arcs. Minor arc, major arc. That is the bigger part of the circumference and the smaller part of the circumference. So, I have a sector. And I've defined an arc also. Listen well. I've defined an arc. What is an arc? An arc is a part of circle cut out by two radii at an angle from the center of the circle. An arc is a part of the circumference cut out by two radii at an angle at the center of the circle. Quite simple. With all this, we can now delve into the circle geometry itself. Having understood all this, from circumference to radius to diameter, from diameter to chord, from chord to sector, from sector to arc. Now we can delve into the properties of, into circle geometry itself. Are we there? Let me leave some seconds for this to sink. Yes, moving forward. Now we delve into what is circle geometry itself. Circle geometry is the study of circle and its properties. Thank God we started from the studies of the properties of circle, which I have explained. Now, for us to solve circle geometry questions, a lot of students run away from this question, especially in WAEC. The moment they see the diagram circle with all those lines, this one will be very difficult. It is not difficult. It is just about theorems, that is, rules and regulations. There are basically 7 theorems attached to circle geometry. If you are able to understand these 7 theorems, you will be able to solve any circle geometry question. Yes, I said so. Let's go. What are the theorems attached to circle attached to circle geometry? Let me call them circle geometry theorems. Circle geometry theorems. There are 7 musketeers, like I call them. 7 theorems to master. The first among those theorems is theorem number 1. It is called the midpoint theorem. It is called the midpoint . The midpoint theorem. What is the midpoint theorem talking about? The midpoint theorem states that whenever a line is drawn from the center of a circle to meet a chord, it bisects the chord and perpendicular to it. Midpoint theorem states that whenever a line is drawn from the center of a circle to meet a chord, remember we defined a chord as any line drawn to touch 2 points on the circumference without passing through the center. That's a chord. Remember? Yes. They said the theorem is saying if you now draw a line from the center of the circle to touch that chord, the theorem is saying this line will divide this chord into 2 equal parts. Meaning, if this chord is 20 centimeters, that means by the time you draw a line to touch it from the center of the circle, it becomes 10, 10. If it is 50, by the time you draw a line from the center of the circle to touch it, it becomes 25, 25. Is that clear? Good. So, it is not just going to divide the chord. It will also be perpendicular. What are perpendicular lines? Quickly. Perpendicular lines are lines that touch each other and angle 90 is formed. Hello? Perpendicular line are two lines that touches each other and forms angle 90 at their point of contact. Meaning, when this line touches this line and they are perpendicular, it means angle 90 will be formed between them. So that is what midpoint theorem is talking about. Now, how do we apply this? We have to apply this. What we normally do is that sometimes they provide for you, I said any line that is drawn from the center of a circle to touch the circumference is what? Is a radius. Meanwhile, I can also have another radius. Meaning, if you have that triangle, if this is center O, here is A, here is B, then triangle AOB is a what? Is an isosceles triangle, meaning it has two opposite sides equal automatically. These angles will also be equal. That is what, although that is not part of the midpoint theorem, but it is what we are going to conclude from the diagram. I hope I'm communicating. Very simple. Nothing more, nothing less on the first theorem. It is called the midpoint theorem. How do we apply it? Let me give one example before we move on to the next theorem. One example before moving on to the next theorem. Example. What is the length of a chord AB if a line 10 centimeters is drawn from the center of the circle of radius 5 centimeters. Center of the circle of radius 5 centimeters to meet it. What is the length of a chord AB if a line 10 centimeters is drawn from the center of the circle of radius 5 centimeters to meet it? From there, we sketch our diagram. This is what you are going to sketch also. So I'm using this diagram still. This is my line AB, which is a chord. Then a line is drawn from the center of the circle to meet it. What is the midpoint theorem saying? The midpoint theorem is saying any line you draw from the center to meet that chord will divide the chord into 2 equal parts. Meaning, if we say here is X, here will also be X. So if you draw out that small triangle O, let's call this N, triangle ONB. What type of triangle does it form? It automatically forms a right angled triangle. They said the radius of the circle is what? 5 centimeters. And they said the line from the center that meets the chord is what? 10 centimeters. So we are looking for this x. So that when we get the value of x, we will then use it to add it together. We just multiply by 2 and get the total length of AB. This is line NB. This is O. So OB is the radius, 5 centimeters. ON is the line drawn from the center of the circle to meet the chord, 10 centimeters. So what is x? From here, we apply what is called Pythagoras theorem. Using Pythagoras theorem. Pythagoras theorem. This is another theorem not on this topic. For those who do not know, Pythagoras theorem is that theorem that states that the square of the longest side of a right angle triangle, which is hypotenuse, is equal to sum of the square of the other two sides. The square of the hypotenuse is equal to sum of the square of the other two sides. Meaning, square of this. Oh, there's a mistake in the question. There's no way this question will ever be correct. There's a mistake in the question. Let's change this to 1 centimeter. Or 3 centimeters, the case may be. Let's change this to 3 centimeters. Yes. So the line drawn from the center of the circle is 3 centimeters. So from circle geometry, it is saying that OB square is equal to ON square plus NB square. What is OB square? That is hypotenuse, which is 5 square, is equal to what is ON? 3 square. What is NB? X square. So what is x? X square is equal to 5 square minus 3 square. X square is 25 minus 9. X square is 16. X is equal to square root of 16. X is equal to 4 centimeters. If x is 4 centimeters, then what is AB? The length of the chord that we are looking for actually. What we have found is one part of the chord. The line drawn from the center is dividing the chord into 2 equal parts. So AB will be 2 times x, which is 2 times 4. 2 times 4 gives me 8 centimeters. That is the length of the chord. Quite simple. That is midpoint theorem. Theorem number 1 of circle geometry. That is theorem number 1. Moving on. Theorem number 2. Theorem number 2. That is how to apply the midpoint theorem. Remember, here, the first example here, they gave us the length of the line from the center of the circle. Another question might not give us the length of the line from the center. They might give us radius of the circle and give you the length of the chord. ask you what is the value of the length from the center of the circle. You apply the same thing. Just draw out the right angle triangle. From there, you know your you know your hypotenuse. You know the value of a chord that can be divided into two, since the line is striking you from the center of the circle. So moving on, theorem number 2. We'll talk about angles in alternate segments. Alternate segment angle. Alternate segments. Alternate segments. Alternate segment, just as the name implies. Alternate segments are segments opposite each other in a circle. It might be more than one alternate segment. It might be more than 2, sometimes 3 alternate segments in a circle. So what does that theorem say? The theorem says that angles in alternate segments are equal. That's all about that theory. No more, no less. What I'm talking about, if I have my circle and I have the center of the circle as something like this, remember I said the other time, a chord will touch 2 points on the circumference but will not pass through the center. So will not pass through the center. If you look at this chord has divided this line, this circle into 2 segments. One part here, one part here. An angle is formed here. Is that? Now, look at this chord again. This other chord. Let me label it. This is A, B, C, and D. Look at it. A, B, C, and D. Chord AC has divided this circle into this segment and this segment. An angle is formed, angle B, right? Good. Also, this chord BD has divided this circle again into this segment and this segment. Another angle C is formed there. Is that not? What the theorem is saying is that this segment and this segment are alternate segments. Segment here, they are alternate segments. Automatically, they are beside one another. They are beside each other. That angle, they said, are equal. Not just that. Look at angle A also. Angle A and angle D. They are also in alternate segments. Automatically, they will be equal. Meaning, angle A is equal to angle D. Likewise, angle B is equal to angle C. Angles in alternate segments. Angles in alternate segments. That's all. That is what theorem 2 is talking about. That is what theorem 2 is talking about. Can we have an example? Can we? Yes. I assume we have something of this nature. Find the lettered angles in the diagram below. One thing that scares students away, the diagrams. By the time they see the big circle and all the lines in it, they're already running. Some are already sweating. You need not sweat. Just study the diagram. Note which theorem to apply. That's all. I have the circle. I have the center. (35°) A, (82°) B, and C. Find the lettered angles in that diagram. I hope you can see the question well. Find the lettered angles. From here, let me call this P, Q, R, and S. Angle Q is 35 degrees. Angle R is A. Angle P is B. Angle S is C. Here is the center of the circle. And the angle at the center here is 82 degrees. So what is A, B, and C? How do we go about this? Very simple. Very simple. Very, very simple. I'm going to zoom so that we can see that angle very well. Hope we can see better now. Yes. Angle Q there is 35 degrees. Angle P is B. Angle towards the center is 82 degrees. Then I have angle R as A and angle C as angle S as C. So what is the value of A, B, C? The first thing to find there, I'm cleaning this. Is there a way I can, okay, let me use it without cleaning. Look at this shape. If you look at it well, you will see that that is a triangle. Are you seeing that? I hope you are seeing it. That is a triangle. That is a triangle. So, in that triangle, we all know that sum of angles in a triangle is 180 degrees. Automatically, from there, I can see angle 35 degrees plus angle 82 degrees plus angle B. Let me try and clean this so that it will be clearer. Yes. 35 plus 82 plus B is equal to 180 degrees. Why? Sum of angles in a triangle. Sum of angles in a triangle. So what is B? Easily we can find the value of B and say 35 plus 82. 35 plus 82, 7. That is 117 degrees plus B is equal to 180. B is equal to 180 degrees minus 117 degrees. 180 minus 117 degrees. That should give you 63 degrees. That is angle B. If angle B is 63 degrees, what is the theorem saying? Now let's go back to our theorem. Theorem says angles in alternate segments are equal. So look at that theorem. Look at it. What I'm tracing out, they are angles in alternate segments. Automatically, we can come back and say A is equal to 35 degrees. Likewise, B is equal to, likewise, C is equals to B. What is B? 63 degrees. Why? They are angles in alternate segments. That's all in that triangle. We have found A, we have found B, we have found C. That is circle geometry. Theorem number 2, ladies and gentlemen. Theorem number 2. Alternate segments. Quite simple. That is alternate segment. We move on. We move on. We move on. Theorem number 3. 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 Angles in a semicircle. That is the theorem. Angles in a semicircle. Angles in a semicircle. Angles in a semicircle. Theorem number 3 is angles in a semicircle. Remember, I told us a semicircle is half of a circle. Any angle formed, the theorem is saying, any angle formed in a semicircle is right angle, meaning it is 90 degrees. Any angle formed in a semicircle is right angle, meaning it is 90 degrees. Any angle formed in a semicircle is right angle, meaning it is 90 degrees. That is just the theorem number 3 in circle geometry. What does it mean? It means if I have a circle, then this is the center. Then I have this. What it simply means is that if this is the center of the circle, this angle is 90 degrees. This angle is 90 degrees. This is another semicircle. You have two semicircles in a circle. 90 degrees here, 90 degrees there. That is what second theorem is talking about. It's as simple as that. Yes, Abdul Samad, we got 63 degrees. Yes. For the second example under alternate segments. For instance, Look at that example. Look at that example. Look at that example. I hope you can see well. Let me zoom it. See it? See it? Question says, find the lettered angles A, B, and C in the diagram above if O is the center of the circle. Remember I told us that any line that runs through the center of a circle and touches 2 points on the circumference divides the circle into 2 semicircles. Very simple. So, line here is running through O, and they said O is the center of the circle, meaning here are 2 semicircles. And circle theorem says angles in a semicircle is right angle. Meaning the first angle to look out for there is what? Angle B. Just go ahead and say angle B is equal to 90 degrees. Why? Because it is angle in a semicircle. Very simple. That's it. Next, look at angle C and angle 145. Where are they? They are both on a straight line. And we know that angles on a straight line, when you add them together, must give us 180. And that was primary school arithmetic now. Don't tell me you've forgotten that. Definitely. C plus 145 degrees must be equal to 180 degrees. Sum of angles on a straight line. Sum of angles on a straight line. So that means C will be equal to 180 minus 145. C is 180 minus 145 must give me 35 degrees. If C is 35 degrees, what is A then? Quite simple. This is a right angle triangle inside the semicircle. We have known the value of B. We have known the value of C. What is the value of A? Very simple. We just go ahead and say E plus B plus C must be equal to 180 degrees. Why? Because they are sum of angles in a triangle. So I have, what is A? I don't know. What is B? 90. What is C? 35. So is equals to 180 degrees. A plus 125 is equals to 180. What is 90 plus 35? Yes, it's 125. So what is A then? A is equals to 180 minus 125 degrees. A is equal to 55 degrees. So that is what angle A, B, and C are. I hope that is quite clear enough. I hope it is quite clear enough. I hope it is clear enough. I hope it is clear enough. At this point in time, before we move on, we want to switch a bit. I'll be going off a few seconds and return back. Please stay with us. Please stay with us. Thank you very much.